Hi guys, we're going to talk right now about dividing decimals, and the I can statement we're working on is I can solve, using addition, subtraction, multiplication, and division, real-world problems involving rational numbers. And the part of this I can statement that we're actually going to work on is using division of rational numbers. And the type of rational numbers we're talking about today are decimals. So let's start by dividing to find a quotient and a remainder, okay? So if I wanted to divide 73 by 2, I would first say, okay, well, how many times does 2 go into 7? And that would be 3. 3 times 2 is 6, and 7 minus 6 is 1. Next, I need to bring down that 3 after the 7 and ask myself, how many times does 2 go into 13? And the answer is 6. 6 times 2 is 12. When I subtract, I get a remainder of 1. Well, we're not always going to be able to leave our answer in the form of a quotient with a remainder. So what do we do then? Well, if I have a remainder and I can't have that in my quotient, I am going to turn 73 into 73 and 0/10. And really that doesn't change the value at all. I can put as many zeros after a decimal point as I want to, and that doesn't change the value. So let's do that in our problem, and then we bring that 0 down. So now I ask myself, how many times does 2 go into 10? Well, the answer is 5, and 5 times 2 is 10. When I subtract, now I have no remainder. But my answer is not 365. I need to, when I'm all done, go back and take that decimal point and just bring it straight up into my quotient. So 73 divided by 2 is actually, 36 and 5/10. That's my quotient. Let's look at another example. So what if I wanted to do 91 divided by 4? Well, as I always divide, I would say, well, how many times does 4 go into 9? The answer is 2. 2 times 4 is 8, and 9 minus 8 is 1. Now I have to keep going, so I'm going to bring down that 1 and ask myself, how many times does 4 go into 11? The answer is 2 again. So then 2 times 4 is 8, and 11 minus 8 is 3. Okay, so now I have a remainder. So I need to turn that 91 into a form where I can keep going without having, so I can see if I don't have a remainder. So I'm going to turn that 91 into 91 and 0/10 because that doesn't change the value of any of the numbers in my original problem. And then I'm going to bring down the 0 and continue to divide. And I'll ask myself, how many times does 4 go into 30? The answer is 7. 4 times 7 is 28, and 30 minus 28 is 2. Okay, so I still don't have a terminating decimal. I have another remainder. So what do? Well, I'm going to add another 0 to the end of 91 and 0/10 and drop that 0 down and continue to divide. So now I'm going to ask myself, how many times does 4 go into 20? And the answer is 5. 5 times 4 is 20, and 20 minus 20 is 0. Okay, so now I can stop dividing because I've got now a terminating decimal that stops. But I still need to go back. My answer is not 2,275. I need to bring that decimal point straight up, and my quotient is 22 and 75/100. So 91 divided by 4 equals 22 and 75/100. Let's look at one more example similar to this. Let's take 82 and divide it by 6. Now I'm going to ask myself, how many times does 6 go into 8? And the answer is 1. 1 times 6 is 6, and 8 minus 6 is 2. Now I need to bring down a 2 and ask myself, how many times does 6 go into 22? And the answer is 3. 3 times 6 is 18. 22 minus 18 is 4. Now, since I have a remainder and I don't want one, I'm going to turn 82 into 82 and 0/10 because that doesn't change the value of 82. And once I do that, I can bring my 0 down. Now I ask myself, how many times does 6 go into 40? That's 6 times. 6 times 6 is 36, and 40 minus 36 is 4. I need to add another 0, drop it down, keep dividing. But look at what happens. I drop that 0 down, I get 40 again. I know 6 goes into 40 6 times. 6 times 6 is 36, and 40 minus 36 is 4. Okay, now I'm going to have to add another 0 and drop it down. And what am I going to get every time? I'm going to notice that I keep getting 40 when I add a 0 and drop it down. So now I have a repeating decimal or a repeating pattern in my quotient, these 6's. Well, once I notice that I have a repeating portion in my quotient there, especially or in the decimal part in particular, I can stop dividing. I'm going to bring the decimal point into the quotient. And since that 6 is repeating, I'm going to represent that by putting a bar on the top of it. So my quotient is actually 13 and 6/10 repeated. What if I have a problem like 4 divided by 5? It seems like that's impossible to do because my dividend, that 4, is smaller than my divisor, the 5. But I can still do this the same way I did the first 3 problems. 5 can't go into 4 at all, but if I turn that 4 into a problem with a decimal by turning it into 4 and 0/10, I now can divide 5 into 40. Okay? 5 goes into 40 8 times, and 8 times 5 is 40, and when I subtract, I get 0. So, I'm not done. The answer is not 8. I still need to bring that decimal into my quotient, and my answer is actually, 8/10. Okay? Now, in this video, there's going to be 2 practice portions. This is the first portion. You're going to turn your paper sideways, just like you did for adding and subtracting decimals and multiplying, and you are going to work out problems 1 through 6 to find each quotient in decimal form. So we're not going to leave it in remainder form. Pause the video. When you finish these 6 problems, hit play, and we're going to keep going. So now we're going to talk about decimal divisors. And before we do that, let's look at a couple problems. You can go ahead and pause the video and divide these 3 problems, or you might be able to do them all in your head. And when you do that, you'll notice that the quotient for each of these problems is 2. So, although these problems might look different, we're taking very large numbers in the first one versus in the third one we're taking kind of small numbers, and although they look very different, their quotients are actually the same. And let's look at some things we notice about problems 1 to 3. I notice, first of all, that if I go from this problem, the dividend changes by dividing by 10. The divisor changes by dividing by 10. To go from problem 2 to problem 3, the dividend changes by dividing by 10, and the divisor changes by dividing by 10. If I work it backwards, I might notice that the dividend gets multiplied by 10, and the divisor gets multiplied by 10. So whatever I do to the dividend, I can do to the divisor, and I'll get the same quotient. It doesn't change as long as whatever I do to one part of my problem, either multiplying by 10 or dividing by 10, I have to do to the other part of my problem. Now, let's look at a division problem. And keep in mind what we were talking about. Whatever I do to one part of the problem, I have to do to the other. It does not change the quotient. But if I have a problem like 10 divided by 5/100, I might want to first ask myself, well, what is the question that this problem is really asking? And the question really is asking, when we're dividing, how many 5/100 fit into 10? I like to think about it in terms of money, because that kind of makes it a little more manageable for me. So I might ask, how many nickels make up $10? Well, if 20 nickels make up $1, then 200 nickels make up $10, because to get from $1 to $10, I multiply by 10. So whatever I do to one part of my problem, I have to do to the other part, right? Or I can think of it this way. 5/100 fits into 10 200 times. Keep that in mind as we move on. You might notice that all of these problems look different, but their results are actually the same. 5/100 goes into $10 200 times. We know that. Well, let's take that 10 and multiply it by 10. Let's take our 5/100 and multiply that by 10. $100 divided by 50 cents, or how many times can 50 cents go into $100? Well, that's 200 times. Let's multiply by 10 again. Okay, so 100 times 10 is 1,000. 5/10 times 10 is 5. I can take 1,000 and divide it by 5. I get 100 or 200 again. If I keep going and multiplying both the dividend and the divisor by 10, I keep getting 200, no matter how I try to do it. So when I get a problem that has a decimal in the divisor, I want to go back and think about this concept, okay, as a different problem resulting in the same answer. And that's going to help me divide by a decimal. So let's look at this problem. 48 divided by 8/10. Doesn't look like something I can really do, but if I change that problem so that I don't have a decimal in my divisor, now it's something I can manage. So how can I get rid of that decimal in the divisor? Well, how do I turn 8/10 into a whole number? I do that by multiplying by 10. So when I multiply 8/10 times 10, I get 8, and the decimal's back here. But if I'm going to multiply the divisor by 10, I have to multiply the dividend by 10, so I get 480. So this is the problem I'm going to solve. And I know I'm going to get the same answer here because I did the same thing to both the dividend and divisor. If this concept makes sense to you, it might be easier for you to think of it this way. I move the decimal one time here. I have to move the decimal one time here. But when I divide 48 divided by 8, I get 60. So I know that 48 divided by 8/10 is also 60. Let's look at another example. 45 divided by 9/100. Well, let's look at some other problems that will give us the same quotient. The first problem here has no decimal in the divisor, so I know this is going to be one that I can solve pretty easily. And when I do that, I get 500. 4,500 divided by 9 is 500. So I know that the other two problems, particularly the one I'm trying to solve, is also 500. So it might seem weird that the quotient is so large, but ask yourself, how many times does 9 cents fit into $45? Now it's time to practice again. Pause the